very happy to be here at Imaginary Conference, so thank you for inviting me here. I'm Alessandro. I work for Curvilinia, that is a startup company focused on innovation and in new means into didactic. We make exhibitions and didactical kits for teachers to bring to schools during lessons, meaning we have an activities focused on 1 hour activities, 2 hour activities for middle and high school. And we also make exhibition to bring into festivals and into museums. We have somehow the spirit that Imaginary has. So we try to make mathematics appealing, visually appealing, and also full of meaning. It's not only the visual part, it's also the mathematical part that is strong. We started some years ago, actually in 2014, as a company. This is an exhibition we made about spherical and hyperbolical geometry, presented first at the Festival della Scienza, the Science Fest in Genoa. It is one of the biggest festivals in Europe. And we try to focus also on interactive things, so the visitors of our exhibition are directly asked to interact with objects, to study some real-life situation. In the blue picture over there, you can see a little model of a train that it used to study the waiting time when I am at the stop of a bus, of a metro, underground. And we also make some statistics about it and some probability study. This one picture is our last exhibition. We made it last year. It's called Matematica Terra Terra in Italian. That can really translate as mathematics down to earth. It's focused on cartography, mainly. And we studied different projections from the sphere of the earth to maps and what the properties are about these maps. They may preserve areas, they may preserve distances from fixed points, they can try to preserve the much they can the shapes of the continent. We also try a new thing in this exhibition, that is gamification. We try to build a little game for visitors to play with, to focus their attention and to try to make them learn something while they are playing. And this is also what I am aiming to do now. So I need 2 people from the public to come here with me on stage. Volunteers, please. Come. Can I choose the next one? Okay. So.
Real game.
Yes, it's a real game. Okay, just a little configuration first. Okay, so you can take those game pads. They work using the right pad. So for start, you can press number 4. Okay, now we have some projection of some different maps we can choose between. So going left and right. You can go left and right to choose different. This is a sinusoidal one, the played card, the Mercator one. Oh, this is kind of tricky. Let's play with this one for now. Okay. The aim of this game is to reach these colored dots. So I'm just here. Okay. There are 6 of them. This one for the green plane, that one is for the red plane. And once you reach one of these dots, you have 3 seconds to reroute yourself, pointing to the next one. So Andreas is still to have. No, this is a visual help that says where the next one will appear. So what the mathematical trick is behind this game? The two planes goes at the same speed. So it's not a game about who is faster to get there in speed, but the one who will get to the dots first is the one who can trace geodesic better than the other player. So you have in order to win, you have to calculate faster than the other player how are shaped the geodesic on this kind of map. Okay, and here we are. So the green player win with the 60.6 second, and Andreas made it in 75 seconds. So you can press number 4 to play again. Yes. You have to press the 4 too. Okay, let's choose a different kind of map. Oh, this is a fuller projection on cube. This is very hard. Okay, so I noticed here you pressed the 3 button. And so what's happening? Who can say me what happened to the red plane? What are those lines? Yes? Yes, this is the metric of the plane, of the projection on the plane. And you can tell by the fact that this angle is not constant, it varies as the dot moves, that this map is not angle preserving. If we did the same thing on the Mercator projection, those two lines would have ever been at a right angle, one another. And also, what's happening? Okay, green win again. Okay, another one. Okay, let's also press the number 2 button on this. So we have also an help, the grid of meridian and parallels on the map that will help us. So I'm asking one more thing to the public. What's happening to the shapes of the planes and their dimension? Are they getting bigger, larger, distorted? Okay, maybe this map is not the right one to notice that, because on this map the planes are always the same dimension, because this map is area preserving. In the map before, we could have noticed that planes became bigger as you approach more distorted zone on the map. And so they work like a Tissot indicatrix on the map. Just not an ellipse, but a plane-like shaped indicatrix. Yeah, near the pole is tricky. Okay. So it's the 3rd time green player won. So congratulations on that. Okay. So what does gamification make possible? It makes possible for us to focus the attention during the exhibition. We usually develop exhibitions that are 1 hour long during visit, so it's very difficult to bring up the attention for such a long time. Also, it makes possible for kids, for middle school kids, but also for high school students, to understand something while they are playing. if you try to explain geodesic in an abstract way to students, they probably will forget or will miss some important part in a very short time. We believe that this kind of experience could really help students to remember what they are doing. Remember also the experience. Sometimes when we came to a single school 2 years in a row, the second year the students remember us for, oh, the ones with the game with the planes, or something like that. So it makes easier for the teacher to scaffold newly acquired knowledge more easily, to bring the knowledge, scatter it in teeny little pieces, and build something upon this kind of newly acquired knowledge. So, if you have any question, if you like to share some experience and bring us some comments, there are my contacts, so alessandro.cattaneo@curvilinia.org. And I thank you for your attention. Thanks.
Thank you very much. Are there any questions?
Do you have some strategies how to gamificate some exhibits? Or gamify? I don't know what's the word. Gamify. Yeah.
I think it's gamify. We didn't translate it into English so well. But no, we don't really have a strategy to do kind of strategy one fits all. Maybe we can focus on the single activities and try to think how to gamify these activities, or maybe only some parts of these activities. At the start, we aimed to do a full gaming experience into this exhibition, but then we settled only to have one game, this one with planes, and then the rest of exhibition is more standard one, although very visual because of cartography, so it's of course visual.
Are there any other questions?
Have you tried to use ancient maps or in some way convey the history of cartography? Because that's also linked to technology. And have you ever tried that to understand how people have developed better maps?
No, in this exhibition we had some historical maps, but it was only at theoretical activities, so more like a frontal lesson. We don't have any interactive activities on ancient map. We used a simple NASA map for all these interactive maps.
Gamification works for all ages in practice?
We tried it only with a limited public, so I can answer with this game, the answer is yes, between 13 years old and an open end. So we have also parents of these youngsters that played with the game and stay also after the visit is over to play again with the single game. So for now the answer is yes, but I can't speak for future kind of exhibitions. So.
Follow up on that. What about gender? Does this appeal equally well to boys and girls?
Yes, for our experience, yes. There were the same numbers of boys and girls which appreciated this game. So one of the features they most asked us is to have a scoreboard with the best time results. And we plan to add it for future exhibitions of this game.
Maybe there's time for one more question.
Hello. Thank you very much for the game. It's actually communicating a lot to us. But if, for example, I'm playing this game and I'm not a mathematician, how do I know the mathematics behind what is happening? So maybe I want to add that maybe you can add a test that will explain what is happening behind the game, so that if I'm a player playing it, I'll know the mathematics that is happening or that is behind the game. It's just a comment if it's
Yes,
good enough.
this was not to think about as a standalone activities, but it would come at the end of an hour-long exhibition. So this is also a kind of test to know if the students that followed the whole path of the exhibition had understood something really strong of the content we tried to bring to them. So this is a sort of a sum up of all the exhibition path.
Okay, well, let's thank this speaker again.
Thank you. Thank you.